Hello and welcome to what seems to be your last lecture in the book. Amazing, right? Reminder that since the last, oops, I didn't mean to download that. Why would I need to do that? I meant to hit present. All right, since the last exam is only 2 chapters long, it's only going to be 30 questions instead of 40. Should be fairly easy. I'll see if I can put together a little study guide for you, like I have been doing. And just a reminder that we're going to be taking this exam next week in the last week of the semester. Sometimes people think that that's not cool because they're in the middle of everything else. And actually, if you were in class right now, you'd also be working on running your experiments this week, actually, is what we would have been doing. And so there was all that chaos involved. But people usually are very happy afterwards when they realize that that means the entire week of finals week. And for you guys, especially if you get it done early in the week, that means that you have all that time just to work on your final paper. So we'll get to that stuff. And I still have to record the little things like how to make a proper title page and how to make a proper how to write an abstract and all of that fun stuff. So we'll go over that a little later this week as well. But for the last chapter, we're going to talk about replicability, generalization, and what to do with this stuff in the real world. So this is the last chapter that sort of wraps things up. In this chapter, there's only really 6 objectives. I will describe the differences among the different types of replication studies that you can run. There is direct replication studies, conceptual replication studies, and one that we call replication plus extension, where you're basically using the beginning to show a replication of the original one, and then it extends it in some other way, which is kind of reminiscent of what you're doing with the seed article into your own study. Number 2, explain what a meta-analysis does and what it has in common with direct and conceptual replication, and how is it different from a journal article, like we've been talking about, a regular study. 3, give examples of how external validity applies both to other participants and to other settings. And describe the difference between generalization mode, in which the actual priority is external validity, and theory testing mode, in which external validity is not only less important, but it may not be important at all. And what are the differences between those 2 types of study with an experiment? I will also articulate the mission of cultural psychology, which is sort of a special case of external validity because you're already extending it to different cultural populations. So you're generalizing it to other cultures. Perspectives of generalization and theory testing modes, that all important studies use diverse random samples as best we can, and the important studies take place in real world settings. As much as we covet the lab setting because it allows us to control for many different things that we can't control for in the real world, if we're trying to generalize a concept to something that happens in the real world, then obviously there has to be some real world application and some experiments that are in the real world, right? So let's get into those things. Overview, remember what qualities of a study make it important. One of the things that if you don't have replication of a study, it may show that you got lucky, that there was a fluke, even if your statistics were good, or that it only worked once because whatever reason. So in this case, in order for you to show that your study was valid, it needs to have replication. It's essential for its importance because it says you didn't just get a fluke, that it worked, and that it worked more than once. For generalizability, which is generalizing it to other populations, to other people, to other times, right, etc. If you're in generalization mode, then yes, generalizability is essential. If you're in theory testing mode, then no. What about real world applicability? Of course, it's never as easy as black or white. It's complicated, so let's get into that. So to be important, a study must be replicable. So what does that mean? Again, if you find the results, even if you get a significant results once and you're never able to get it again, then who knows what happened that first time. That's why replicability is essential, because it basically backs up that what you did and got right the first time, you did again and found the same result. Otherwise, you can't really do much with that. So, looking at replication studies, we'll talk about importance and weight of the evidence. What is a meta-analysis and how is it different? And replicability as told in the popular press and not just in journal articles or meta-analyses. So what are the types of replication study that we're talking about? Replication, which is a direct replication. Remember when I talked about in the method section, the reason that we have a method section in a paper is so people know exactly the variables you used, exactly how you define them, exactly the procedures that you did from start to finish. Because if they wanted to replicate your work, they have everything they need right there to be able to do it. They don't need to call you and ask questions. They don't need to clarify it somehow, right? They have everything they need. So it's a specifically direct replication, a carbon copy of the way you did it originally. Conceptual replication is doing it, but maybe not using exactly the same operational definitions, but using the same conceptual definitions. Remember in chapter 3, we talked about that, right? The conceptual definition of texting while driving is obviously texting, sending a text while driving. But the way that we observed it or took a survey, right, self-report or something like that could be measured in different ways. So conceptual replication is replicating the experiment, the essence of the experiment, but not necessarily to the same direct T. So I'll give you examples of that. Replication plus extension is using the replication originally and then showing how you take it a step further. So if we were to do the Stroop task again and then add another group that had high and low levels of lighting or had the letters jumbled, and to see if that would cause more interference or if it would sort of cancel it out, that would be a replication plus extension. What about replications by independent researchers? It's said that if you can replicate your own experiment, that's obviously a really good thing, but it's even better if it's replicated by independent researchers. So another lab in another country or another state or somewhere that's not you. Why is that given more weight? Well, in this case, and we'll go over this again, because if they followed the exact same protocol basically that you did and got the same results, it means that there's definitely, right, without consulting you or running through exactly the same things you did, they found the same thing. So that's better than if you were to replicate something yourself. We'll talk about that. And then a meta-analysis. What do all the studies in this area say overall? So direct replication, again, is doing it exactly like the first one was done, step by step to a T. In this case, this was a study called the birthday similarity effect. So they had somebody talk to other people, and there were two groups. In one group, the person was just talking to the other person and they didn't really have anything in common that they knew of. And they just had a conversation. And then the person was asked, how much do you think you would like this person if you got to know him or her? How much do you look forward to getting to know this person during the upcoming conversation? And all of that. So in the control group, there was they weren't matched for anything, but in the experimental group, they were told that this person had the same birthday as them before they talked to them. So again, how much do you look forward to getting to know this person who's basically your birthday twin? And how much do you think you would like this person if you got to know them? Birthday twin. So in study 5A, you see a huge difference in overall liking from a 7.2 to an 8 over an 8.0. And in study 5B, although you don't see as huge a difference, you still see a significant difference. Again, the liking overall about a 7.0, just like the first one. And the other one is, the liking goes up to maybe a 7.6, 7.7 instead of an 8.0, but you basically get the same effect. So you're able to replicate this with a different group in a different area and get the same effect. A conceptual replication, again, is using the same conceptual variable, maybe not exactly the way that they measured it the first time. So here, the conceptual level is serving container size. So on the operational level, we could have bowl size, large or small. If you remember back from chapter 10, we talked about having that pasta in a bowl, medium or large, in this case, small or large. It could be popcorn in a box, small or large, or it could be something in some drink or some oil or something in a bottle, small or large. But either way, no matter which one of these you do, you're still replicating it based on the conceptual definition. Dependent variable is still the amount consumed. So the bowl size could be a bowl of chips, and you could count the number of chips consumed. The box size could be popcorn, and you can determine the number of ounces that were eaten. Or again, bottle size, the amount of oil that was used, or dressing, or barbecue sauce, or whatever it is, right? I won't say ketchup because I don't like it. So you're doing it conceptually. Again, the replication plus extension is replicating the original experiment and then adding a new one to it. So you're basically showing replication by doing the first experiment again as a replication, and then you're extending the study to add more variables or another study or things like this. So originally we have driving versus driving on a cell phone. Here day one is no practice, just like we saw in the original one, and to see how much collision frequency there was. And then day 4 is after 4 days of practice. So on day 1, which is the first part of the experiment, they are replicating what was done before, and then they're adding day 4 with 4 days of practice to see if the results are the same. And we see that there are reductions in collision frequency for both, but the difference between driving and driving on a cell phone seems to be about the same if we're reading the graph. Here we have the braking onset on baseline, and we want to see if driving over the legal limit or using a cell phone is the same thing. Here, even with what it shows, even with a blood alcohol content at the legal limit, it's about the same amount of time to brake as baseline. But when you're on a cell phone, you're even more distracted. So if you were to take this to heart, you could say that driving while using a cell phone looks to be more dangerous than driving drunk. Would I agree with that? Again, context being what it is, probably not. But if you were to take this graph as everything, then maybe you could make that argument. Looking for braking force, we see that baseline and driving while using a cell phone are the same, and driving driving over the legal limit seems to have more force in that. So would you want to make the argument that you'll brake harder so you'll be safer with a blood alcohol content that high? I wouldn't do it, but maybe you could argue it with somebody that doesn't need so much convincing. Again, not the best thing to argue, but based on the graph, that could be a conclusion that you would draw. Unless you think they'd just be more likely to give you whiplash because they're braking so hard. So again, replications by independent researchers, more weight seems to be given to replication studies that were conducted by independent researchers instead of the lab of the original experiment. Again, this is the part where I ask you why, and you raise your hands and give me all these amazing answers because I know you would. But for now, we'll see. When a finding cannot be replicated in a different lab, it calls into question whether the original result can be obtained. Were there other special circumstances that we didn't control for, things that we couldn't control for? Was it a different type of mouse in the study? Was it a different type of whatever in the study? Were there things that would work on the West Coast that might not on the East Coast? Maybe. So if let's say we're on the West Coast, if we do something and get a significant finding and it's repeated on the East Coast or in another country, and they find the same thing, or at least significant enough difference that's very close, then that's given more weight because they're saying even without whatever conditions we had in our lab, they were able to get it as well. So this is why it's given more weight in this case. Because even if we get a replication, there could have been some other special thing that we didn't take into account that caused it to work that another lab can't replicate. So if another lab independent of our own, right, is able to get the same result we are, that gives it even more weight. That's the reasoning behind it. So looking at it, replications, importance, and the weight of evidence. We know a single study, although it's good if you get results, is really only important if it can be replicated because it shows that it wasn't a fluke. What your p-value less than 0.05 tells you is that we didn't get these numbers by accident. We didn't get these numbers randomly or by chance, but it doesn't mean that the result itself couldn't have been somewhat lucky. If we get a replication, even just once, you don't have to get 4, 5, 6 replications, but if you get 1 or maybe 2 replications, you're basically golden in the science world, right? Even statistically significant results have to be replicated because, again, although you got it, there may have been some luck involved or some flukishness, right? And if we really want science to progress, it really only progresses through the replication of studies. Looking at a vaccination for the coronavirus, right? There are places claiming that they have a treatment that has helped 100% of the patients. Sometimes that has been, if you saw it on Fox News, there was a fake report. That's where the president got that whole hydroxychloroquine. Actually, nope, that's not it. I'm looking at it because my wife actually takes it. Yep, hydroxychloroquine, right? So the last thing in this portion of the chapter says, sometimes we have reports, obviously, that are from journal articles, which is the first time it's done, or it's a replication, and you get the results of that specific study. But especially now that you guys had just finished researching 2 additional articles for your first submission, there are some types of articles that show a different type of information than journal articles. And what a meta-analysis is basically it's a summary of all of the studies that were done in that or on that topic and what overall do they say. So one of the biggest things that people ask is violent video games and our behavior, right? All of these school shootings and all of these mass shootings that have been happening recently until coronavirus came and took the crown. So we know, just taking Psych 1, you probably have heard at least that there are some studies that say that there is a correlation between violent video games and violent behavior. A lot of studies say there's no correlation between it and there's no causation. So what a meta-analysis would do is it takes all of the studies into account that have been done. Sometimes we can see if the studies are a little weaker or a little stronger, but it's telling us overall what percentage says this. So, such and such percentage says that video games lead to violence, such and such percentage of studies say that they don't lead to violence, right? And things like that. Another example that we'll talk about is religiosity and depression. What does the literature say about people that are religious and the amount of people that are religious that also get depressed? So looking at, remember the effect size guidelines for a correlation is 0.10, 0.30, 0.50, small, medium, and large effect size. For Cohen's D, and I know you guys just did this in the exam, third exam, is 0.2, 0.5, and 0.8, or 0.20, 0.50, 0.80 if you're looking at the difference between groups, like group means. So basically, on the right, we have correlations. On the left, we have causal claims, right? So what we would be looking for religiosity and depression is What are the values that tell us what people say? Does being more religious lead to less depression and things like that? So looking at violent video games and behavior, some of the things that meta-analyses take into account is looking at the overall number of studies that were measured based on aggressive behavior or pro-social behavior, which is helping behavior instead of violence. It's the opposite. And what about the number of studies that have looked at empathy for other people suffering after playing a violent video game? So we see that there's 45 studies on aggressive behavior with about almost 3,500 participants total. And we're looking at the average effect size. A lot of times a meta-analysis will spit out a number. We're not looking at the same types of group means and things like that. We're looking for relationships and what the overall outcome of the studies tell us. So is there a value, is there a positive value, and what is the effect size on violent video games and aggressive behavior? We see that there is an overall 0.181. And if we remember back to the last slide, we have smaller weak 0.10 to 0.30, 0.30 to 0.50. So here we have a 0.181. So what it would say is that there is a weak, pretty weak effect size. And it is positive, but it's pretty weak. So here, what about pro-social behavior? We actually see a -1, of course. Only 8 studies, 875 people. But we see a negative relationship, -0.16. So again, still a weak effect size, but it tells us that there's a negative correlation. So we don't see so much pro-social behavior. Again, it would be more antisocial or aggressive, which is consistent with the other 45 studies. And what about empathy? Same thing, -0.148 or almost to 0.15. So again, a rather weak correlation, a weak effect size, but again, you see a negative relationship for empathy. Looking at table 14.3, what about the impact of violent video games on aggressive behavior, categorized into how well the study was conducted, methodologically weak versus methodologically strong. Looking at the number of studies and how this was determined could have been experts, peer reviewers, looking at the studies and determining these are kind of weak in the way that they were run, and these are really strong in the way that they were run. Let's see if there's a difference. Well, looking at the number of studies, we have 61 that were done that were methodologically weak, and 79 that were methodologically pretty strong. Of those 61 numbers, there was over 46,000 people. Of the methodologically strong ones, 21,681 people. So looking at the average effect size, for the weak ones, you only get about a 0.16, which is again in the weak range. 0.10 to 0.30 is weak to moderate. If you look at the strong ones, a lot less number of participants, more studies, but you get a larger effect size. So you can detect an effect better when you have a much stronger study. So here, 0.244, almost 0.25, which is close to the 0.30 that's moderate. So you get a better effect size when your methodology is a lot stronger, right? Based on the same information. So again, this is telling you in a meta-analysis, the overall number of studies, is there an overall relationship? What do they say? How meaningful is effect size? Depends on what you're looking for. We know that smoking and lung cancer has a really high correlation, and we know that there is a huge amount of a correlation between those two. Media violence and aggression seems to be a little higher. Condom use and sexually transmitted diseases, or now they're called STIs, sexually transmitted infections, have a negative correlation, which is what you want to see with effect size. Passive smoking and lung cancer or secondhand smoke, exposure to lead and IQ scores in children, we see a negative correlation. Nicotine patches and smoking cessation, a little smaller calcium intake and bone mass, right? All of those people that say to drink milk, I think it only helps till a certain age when your bones stop growing. Homework and academic achievement, you would hope would be a little bit bigger. exposure to asbestos and laryngeal cancer, cancer of the esophagus, basically, and the larynx. I guess that would be esophageal. And looking at self-exams and the extent of breast cancer, there's a smaller correlation there. But obviously, like we said in statistical validity, the larger the effect size, the better for everything. So we can still look at these overall meta-analyses and have a good idea that there is some relationship. And this, again, is looking at it overall. So strengths, of course, of the meta-analysis is that you can take a lot of information, a lot of different studies, and look at what the results are overall from those studies. But we have a problem called the file drawer problem. A lot of times you may be picking and choosing specific ones, and you're looking at ones that, you know, it's kind of like you're pulling them out of a file drawer. That may not be the actual extent of studies. And in fact, if you look to the second one, even though all of these studies that are published are there for you to pick from this file drawer, right? The fact that these might not be even close to all of the studies that were done. What about the studies that never yielded results or had the opposite results of what most of these say? What if there were ones that talked about media violence and people or video game violence and helping behavior, and they were good? A lot of times these publications are not going to be published because that's not the cool finding, right? So if we think about things like antidepressants and depressive behavior or depressive symptoms, there may have been many times that studies were done and they did not find a result. And in this case, when you want to know that antidepressants actually help people with their depressive symptoms, I would venture to say that a null result or an antidepressant that made people more depressed, those studies should be published because it's a big deal when there are no results. If you're expecting these things to work and everybody raves how good they are and how effective they are, if you find studies where there's no symptoms or your depressive symptoms worsen, that's definitely worthy of being published. But sometimes you're stuck with the file drawer of the things that worked and the things that got published. We just don't have the ability to choose from all of the studies that never got published because of this, right? Again, we talked about sometimes how null results could be just as interesting, if not more, than getting results, such as gender differences, right? We all talk about gender differences and how men and women are so different in so many things, but all of these studies that show that there's almost no difference between men and women on a lot of different issues, right? It's just not cool. It's not sexy in the media to report those things. Then you can't have all those fun morning show DJ games and things like that. So that's one of the limitations here of the meta-analysis in that case. Looking at replicability in the popular press, again, journalists, when they hear something and it's cutting edge, especially now when we talk about vaccinations and things like this, right? This is really an area where replication, multiple studies, really needs to be done before it can come out to the public. If you get one really good result the first time and it worked for everybody and everybody's happy, we don't know the justification or the ramifications if there was some sort of fluke in there. So we need replicability. Journalists are looking to see who's winning the race on the vaccines and could we have them out by next year or by September. There was an article today I read that said vaccinations could be out by September in the UK. Good for them. Are they farther ahead than we are? Are their testing, right? Is their testing less rigorous than the FDA here in America? We don't know. But a responsible journalist will not only report on the latest and most exciting studies, but also will summarize any other body of literature or if this study had been replicated. There are some responsible journalists in this world. You know, the mainstream media, or as Trump would call it, the lamestream media. But we also know how many wouldn't do this. And so it's just, remember, as good consumers and producers of research, as we're coming full circle to the last chapter, you guys should be able to recognize that better than most. So, the last part of the chapter asks, to be important, does a study have to have external validity? Well, if you remember in our first type of claims, right, we talked about external validity being the top priority if we're trying to generalize a poll or a survey or something like that. For correlations, we said it depends, and most of the time for a causal claim, that it depends on the study, right? On the scope of the study. So this is where we're going to talk about things like theory testing or generalization mode. For the most part, in a causal claim, external validity had the lowest priority. But again, we use the phrase, it depends. So what is external validity? Just to remind you, generalizing to other participants, to other settings, maybe even to other time periods. The questions we ask is, does a study have to be generalizable to many people? Again, if you go back to chapter 8, we talked about it depends on who your population is. There could be a really small population, or there could be a really big population. So that would probably have an effect on generalizability. How many people that are Catholic priests are also baseball fans or something like that, right? If that's your case, then maybe it doesn't have to be that generalizable. But if you're looking for sports fans in general, that's a huge population of this world, right? And then we ask the question, does a study have to take place in a real world setting? Well, we know that for causal claims, as we've talked about, that the lab setting is actually ideal because you can control for many things that you wouldn't be able to in the real world. But when we are coming up with theories, just remember that our theories should have real world application. We're not looking in a vacuum or in a lab setting for these. We want to know that studying, if we go back to the original, I know, again, we're at the end and this was at the beginning. If we're asking, does studying help people do better in school? Or specifically for our first hypothetical experiment, does studying help on an exam, right? We hold it in a lab setting so we can make sure that everybody, all things are equal, right? That we control for as many things as possible. So in this case, did we all eat the same thing? Did nobody have caffeine? Did we get the same amount of sleep? If we can control for all these things, we can say that it works in this setting. But we also, when replicating, need to know if it works in the real world, right? And we need to be able to replicate that in order to say it's a thing. So, reviewing on external validity, we're looking at a population, not the population of the world. So again, I can go with Catholic priests who enjoy baseball. That could be one population. College students is a population, right? We're not looking at the population of the world unless it's something that applies to every human being, like air quality or something like that. So when we're looking to replicate to a population, not the population, remember that external validity comes from how, not how many. Although for statistical validity, you up your sample size and things like that. We also learned in chapter 8 that 50 people randomly sampled was better than a convenient sample of probably 200, right? So was it a random sample, or was it some sort of convenient sample like a snowball? Remember that just because a sample comes from a population doesn't mean it's going to generalize to that population. And so we just have to keep that in mind as we're going through this. So does a study need to be generalizable to many people? We have two different modes, and you should probably recognize by now at least the sort of outline of what these are. In generalization mode, the idea, once you've already gotten a significant result, is you want to be able to generalize it to more people or more places or settings. So frequency claims are the ones with one variable. Those are the ones where you have surveys and polls, and this is definitely done, right? You want to know who the American people are voting for their next election. So in frequency claims, the goal is to make a claim about the population. If we're looking to do market research and we're giving surveys and polls out to people who buy brand X bikes, we want to know which type of people buy it and maybe why. So in this case, we definitely have real world matters. Who we're going to vote for, which brand of bicycle or which car are people buying. External validity is absolutely essential in generalization mode. In theory testing mode, these are more of the association and causal claims. At the beginning, the goal is to test a theory and to isolate variables. This is why it is preferred to have an artificial lab setting to a real world setting. We are prioritizing internal validity in this case, especially in causal claims. In association claims, there's no internal validity. But in a causal claim, obviously internal validity is the priority. So in this case, we require and almost prefer artificial situations because you can control for so much and keep things constant. So in this case, first we want to know that the theory actually works when it's controlled for before we can see if it comes to the real world. So the real world stuff comes later. In theory testing mode, if you find that people do in our class, right, that we do find that those that studied 6 hours a week did better on the exam than those that didn't study at all, then we can say, okay, now that we've seen it, the only thing we can say is that it worked in this class with you guys. But will it work somewhere else? So we'll try it in another class at ELAC, or we'll try it at West LA College over by my house, or we'll try it at, somewhere in Abu Dhabi. Who knows, right? Try it with a high school or a middle school or elementary school. External validity at that point is not the priority unless we get it to work in theory testing mode. So just in theory testing mode, we just need to make sure the theory itself works before we worry about if it works for other people. It has to work the first time, right? So again, remembering the 4 validities and the 3 claims. In a frequency claim, we're asking, in construct validity for all 3, we're asking the same question. How well did they define or measure the variables? So for a frequency claim, we have 1 measured variable. How well was that 1 variable measured? In an association claim or correlation, we have 2 measured variables. So how well did they measure each one? Remember, now you know, towards the end of class, we call them the predictor and criterion variables. And of course, for causal claims, we have at least 1 IV with 2 levels and 1 DV. So how well did the researcher measure the measured variable and manipulate the manipulated variable? Statistical validity. For a frequency claim, we're looking for the margin of error of the estimate based on 1 measured variable. Association claims ask effect sizes. What is it? Is the association strong? Is it statistically significant? If there's a relationship, is there a type 1 or type 2 error? And is it curvilinear? Is it something, right? Those are the things that we ask in statistical validity. Of course, for a causal claim, again, we're asking about effect size, which has to do with sample size. And if there's a difference, how large is it? And is it, of course, statistically significant? So, of course, both of those validities count in all 3 claims. External validity, well, we'll get to that in a second. Internal validity has nothing to do with a frequency claim, because there's no cause. You're looking at 1 measured variable. Correlation does not imply causation. I know you've missed me saying that. And only counts in causal claims. Was the study an experiment? Does it achieve temporal precedence? Does it achieve correlation, right? And does it control for explanations? This is why we don't use a real world setting at first for the most part, because we need to control for these other things. And then, of course, the other internal validity threats that we examined: maturation, history, aggression to the mean, attrition, all of those things, right? Instrumentation, all the dirty dozen. Only applies to causal claims. External validity, which is what we're sort of concentrating on, asks in all 3, to what population, settings, and times can we generalize this? In frequency claims, again, it is the priority, which are in generalization mode. For correlations and for experiments, it depends. In theory testing mode, we're not concerned with other things. We need to know it works the first time before we can worry about if it generalizes, right? So generalization mode, again, we're looking at frequency claims, opinion polls, epidemiological estimates, like how much of the population is diagnosed with depression every year or things like that, and maybe others. Again, market research and things like that. So when we're generalizing, one of the things we generalize to is other settings. And so we ask if something has, as a sort of an offshoot, a subcategory of external validity, we ask, does it have ecological validity? So what that means is, ecological means, does it actually generalize to the real world? So we're in a vacuum or a lab or a artificial setting, and we see that something works. And when we are generalizing, we want to know, does this actually work in the real world? Will this be a thing that if we couldn't control for all of these other variables and blah, 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 would it still work? So asking about ecological validity, we're asking on whether a laboratory study, once you find in theory testing mode, yep, it worked, studying did cause people to do better than not studying, that's when we see if it has ecological validity, and we say, will this work in a real world setting? Because if we're looking to test things about the world, then we want to know that it'll work in the real world, right? So this is when you're going from theory testing mode with a significant result, statistically significant. Will it work in the real world? In generalization mode, again, frequency claims, polls, epidemiological estimates, and the like market research stuff is always in generalization mode. The goal is always to see how many people it generalizes to, how many people in that population. Association and causal claims, sometimes they're in generalization mode. Most of the time it's causal claims when you have already shown in theory testing mode that there is significance, then that's where you go from there, right? So why would we say that cultural psychology is a special case of generalization mode? Because you can run a study on multiple cultures at once, and already you're generalizing to other cultures or other settings, right? Other people. And so it basically does it for you. So here is something that you may have seen before called the Muller-Lyer illusion. And you see that there's line A and line B. And of course, I have none of you with me in front of me to answer this question. But if I were to ask you, which of those lines in between the arrowheads, the ones pointing like up or the ones that are out and sort of upside down arrowheads, which line is bigger? What most Americans say, as you see all the way on the right, is Evanston, Illinois. Most people, just by looking at this picture and not really paying much attention, they would say, oh, B looks like the bigger line. But really, it's the reason it's called an illusion. It's because of the way that it looks to you when extended. So if the arrowheads are backwards, upside down, and it looks like they're an extension, it makes that line look a lot bigger. When the arrowheads are pointing in, it makes it look smaller based on the arrowheads. So if you were to take away the arrowheads and just look at the lines, they would actually be the same size. There is no difference between A and B. And so what you see is SAN and SA minor, you see hardly any degree of illusion because they, for some reason, whether it's a background foreground thing, they can see that the lines are the exact same size. It's a little bit bigger of an illusion in some of these other cultures. And if you go towards, as you get towards South America, or SA European and Evanston, Illinois, you see that the amount of this illusion gets bigger. So people in Illinois in the Midwest would swear that B is a bigger line than A, even though they are the same line. So you can test this one thing on different cultures and basically get a generalization. Again, I think one of the things that I mentioned to you guys, I know I mentioned this to my Psych 1 class, is that figure and ground is a special case of generalization mode, especially because we know that on the West Coast, people tend to see the figure first and then look at what's in the foreground or the figure portion and then look at the background. So looking in the top picture here, most people on the western side of the world would tend to see the fish first and then see the background of the plants, and there's a little, looks like there's a little frog back there, and maybe a little seashell So looking at the picture with the original background helps to give context to the picture. If seen with no background, it may be a little different, or when the fish is put into a novel background, that may cause things to be interpreted differently, especially if you were used to looking at the background first, like the little frog and the plants and stuff like that. So the difference between figure and ground, or the main part of the figure and the background, is also a special case of generalization mode, because different cultures see it differently and they may interpret it differently. And that way you can see if one thing generalizes to the Eastern versus the Western hemispheres in terms of how they see a picture, or how they interpret it, or how they analyze it. Again, looking with Japanese and North Americans with the original background, Japanese, same background. Remember, they look at the background first. Accuracy was better than the US, than North Americans. With no background and not having the background in there, just showing the picture itself, it was better, or a new background that wasn't the original background. We see that North Americans got more accuracy than Japanese. And again, that's because on the eastern side of the world, they tend to see the background first. So if you take away the background or put a different background, that may cause them to have less accuracy in looking at the picture later on. So theory testing mode, again, is testing theory. We looked at Harlow's study, which actually, instead of just having one theory and seeing if it's correct or not, we pit theory against theory, or he did. Harlow, there was the contact comfort theory, where the monkey, as you see on top, went to the terry cloth monkey as opposed to the wire monkey that had food, which was called the cupboard theory. So when you put theory against theory, right, one wins out and one does not. And even with replication, the contact comfort theory was held strong. In the book, there's a parent as grammar coach theory, where you talk about how to correct people's grammar. But mama isn't a boy, he a girl. That's right. There's the animal farmhouse. Nope, that's a lighthouse. I'm not going to go into that right now. I'm not testing that. So if you want to read that theory, by all means, go for it. But at this point, I'm not really worried about it. So one thing we know is that the type of participants that are used in these studies are referred to as weird, not strange, but weird, which means Western, educated, industrialized, rich, and democratic, which means most of the time, 90% of the studies that are done on people who tend to have a better education, tend to be more industrialized, and not like third world countries. So most research in psychology has been done in the US, in North America, in Canada, on college students. They get participation, you get course credit, things like that. You guys are very familiar with this by now. And so what that does is it shows us that it's sort of biased towards one sort of demographic, right? And that there isn't enough done culturally. The other countries have increased in the last 20 to 30 years in this, but a lot of the stuff that we base it on is our own, right? If America wasn't self-centered enough, look at all the psychological research, or majority of it, right? So the last thing really that we're going to talk about is asking the question, does a study have to take place in a real-world setting? Well, like I said, in theory testing mode, the goal is to make sure the theory actually works. So we're trying to control for as many things as we can. Here we see on top, we have the terry cloth monkey again, and on the bottom is the Milgram study. If you guys are unfamiliar with the Milgram study, it was a study on obedience to see if people would listen to somebody and deliver what they thought were painful shocks that might even be enough to kill a person. And in that study, about 2/3 of the participants, who were just regular run-of-the-mill white guys in Northeast America near Yale, went all the way to XXX 450 volts, thinking that they were shocking someone for giving them wrong answers. And even though the whole thing was fake in a lab setting, it absolutely felt real. And the participants really thought they were shocking somebody. Obviously, that couldn't happen these days because we have these ethics committees to take that into account. But the trade-off, of course, for a study back then is you got the real results. You got the real raw emotional data. So, so theory testing mode does require the settings. In Milgram's experiment, if only one other person in there said, maybe you shouldn't be shocking people, that probably would have stopped a lot of them from doing it, right? But even lab settings can really feel emotionally real. And this is a term we call experimental realism. In the Milgram study, they really thought they were shocking somebody. And that really leads to, can ordinary people be coerced by authority into doing really horrible things? And this came from the whole idea of Nazis and World War II and the Holocaust, because years later, a lot of Nazis were interviewed and they said, why did you participate in that? And they said, I wasn't killing people, I was just following orders. So if the people really thought it was the authority figure that was doing it, they were just pushing the buttons, then we can see how normal people could possibly do unspeakable acts. And of course, in an experimental setting, in a fake laboratory setting, it still feels really real. So again, when a study takes place in the real world, when it takes place in a lab, it can still feel real. If you guys were to take an exam in a lab setting, well, it was really in the same setting where you take an exam anyway, right? We were just able to control for other things. So a lot of times lab research can be just as realistic as the real world, and it can feel really real. And we call that experimental realism. When a study does take place in the real world, we call it a field setting as opposed to a lab setting. And of course, if it's done in the real world, then it has much higher external validity than when it's done in a lab setting. So looking at generalization mode, external validity is most important in generalization mode. So having a representative sample is absolutely paramount. It's absolutely essential. When we're looking at ecological validity, that's taking something from a lab setting and applying it, does it work in the real world? It's also important to consider in terms of generalizing to non-lab settings. What things can we not control for? Are we still going to get the same result? Well, in a real setting, we can't control if students are taking caffeine or not. Most children, we would think, right, if you're thinking about it this way, looking at a way to take a lab setting, most children are forced to eat at least a semi-healthy meal, or at least eat something of health importance for breakfast from their parents. Most children have to get at least a good amount of sleep, if not, right? And most children under, let's say 12, are probably not going to be consuming any caffeine. So maybe if we're looking for ecological or ecological validity, maybe for that studying example, we can test it on, let's say, elementary or even middle school children. They have the class schedules that are kind of like high school and college. They are probably not consuming as much caffeine. So maybe we can generalize it to like a middle school setting from a college setting in the real world, because you'll have some of those same things. You can't truly control for it, but you would think they're still getting better sleep than a lot of college students. They're probably eating at least something for breakfast as opposed to nothing, or just, a bag of sugar, and probably not consuming caffeine yet. In high school, especially these days, it's a crapshoot. So maybe for ecological validity for that, we could think of it in terms of, let's replicate it in middle school students. In theory testing mode, again, when you're in theory testing mode, external validity, real world applicability is not important, because you just need to know that the theory actually works before we can see if it's replicable. So once you get a study that works in a lab setting, let's say the Stroop task works, now we want to go see if it works elsewhere. So once you've shown it in theory testing mode, then you're kind of shifting to generalization mode by default, right? So responding appropriately to the latest scientific breakthrough, some of the things we'd want to say, was that result replicated, instead of, oh, we found a vaccination and it works, let's run with it. Well, was it replicated? We need to know this to know that it's actually got applicability. That's a single study. How does it fit in with the entire literature? You don't want to say, look at this single interesting result. Oh, they've got 100%, 100% on this vaccination. Let's go. Good. Get it out to the public tomorrow, right? Let's not yet. You want to say, how well do the methods of the study get at what the theory we're testing? Not, I don't think this study's important because, the methods really had nothing to do with the real world and it was a fake setting. And, well, again, let them get there. Was the study conducted in generalization mode? If so, were the participants sampled randomly? Because you don't want a convenient sample in that case, right? You don't want to say, I reject this study because they didn't use a random sample, or this is a bad study because only used weird people or North Americans as participants. You do want to say something like, the study had thousands of participants, but we're asking, were they selected in a way to allow generalization to that population of interest? That's a very responsible way of asking about external validity, not, oh, they used thousands of participants, so obviously it has to have great external validity. Maybe they grabbed participants from a Republican National Convention. Is that really going to be generalizable? Maybe in Texas. Finally, would the result hold up in another cultural context? Or would that really apply in other settings? If it was in a lab, would it apply in a real world setting? Does it have ecological validity? You don't want to say, oh, that psychological principle seems so basic, studying causes you to do better on an exam, that I'm sure it's universal. If you don't test it, you can't make claims like that. And to do so as a researcher, as you guys well know now, would be utterly irresponsible. So this concludes our Chapter 14 lecture. This concludes all of the lectures that we have in the class. And folks, all we have left after this exam is our papers. First half, you'll get your edits back from me. And then the second half, your results, your discussion, and a couple of the things I'll be talking about tomorrow. And that's it. We are here. It's all getting real, guys. Thank you for sticking with me through this journey. And as always, I will talk to you soon.